Welcome, everybody. Hope you are doing well, recovered from the holidays, first round of holidays, and enjoying our winter. So today in our final session, we will be first going over the demonstration worksheet, and this is the last section of the 8712 document. And this will give you an opportunity to work with the information and go through a simple scenario that depicts a sort of complete nitrogen budget. And then Patricia Lizicki is going to lead us through a case study and on an organic processing tomato farm. And then we have a couple remaining questions that we didn't get to answer from session 2, and then we'll open it up to any questions remaining from the group. And we were not able to get a grower panel together for today. However, we have quite a number of experienced growers and advisors in our group. So I also have some questions I can pose to the group to engage in some group discussion and sharing of experiences. And then we hope that you all will complete our workshop survey so that we can continue improving our workshop and hearing what you appreciated and valued. So that's what we have in store for today. And let's go ahead and get started. So in section 4, you will find the demonstration worksheet. And this is based on a typical scenario that I work with here in Yolo County of a diversified organic grower. And so I'll walk through this scenario together. So I've been an organic farmer for 12 years. I am a year-round diversified vegetable farmer, but fresh market tomatoes are an important crop. My mid-season tomatoes follow a cover crop, and I typically add compost just prior to planting. Also at that time, I amend with a granular fertilizer. Then during the growing season, I run a liquid fertilizer 3 to 5 times during the rapid growth phase. My tomatoes are drip irrigated. I test the soil 1 time per year, and the tomatoes are transplanted in early May, and harvest is complete by mid-September. The soil organic matter is 3%. So perhaps that sounds familiar to some folks, hopefully. So let's walk through how to create a budget for that type of an operation. Okay, so the first goal is to set a nitrogen demand goal or estimate. And we provide 3 ways to do that in our worksheet. And the first way is the most simple way, which is to find a reliable source and pull that number. So we have some tables in the 8712 document. So I pulled from that table and chose 240 pounds. We also provide some multipliers here so that one could enter their own data for a yield and adjust. But in any case, if you have your own information, you can use this information to adapt it or pull from a reliable source. And it's always helpful to consider where that information came from so that you can adapt your yields accordingly. In California, a lot of the published yield data is coming from conventional production and in regions that are optimal conditions for that crop. So the yields tend to be quite high, and you can use that information to adjust accordingly. So we've set a goal of 240 pounds of nitrogen per acre. That's the first step. Okay, the next step is to think about our soil organic matter contributions. So these are going to be, you can consider both your soil organic matter percent and the history of soil building with things like cover cropping, compost amendments, and overall nitrogen management. And so for soil with a longer history of building soil organic matter, you can estimate a higher nitrogen release versus those with a shorter history or with soil organic matter on the lower end. So to start working with soil organic matter, you'll want to pull up these figures from the 8712 document. So find your location. Okay, so I'm located in the Sacramento Valley. I said that my soil organic matter percent was 3, so I'm going to follow this column. And then I plant in May and harvest in early September. So I'm going to tally up mid-May through mid-September and use those numbers. This figure down below can also be used. It's essentially just a different representation of the table. Oops. So I've been farming organically for 12 years with these annual cover crop and compost applications. So I believe that my soil organic matter and the nitrogen bank have been building for many years. Therefore, nitrogen mineralization may be higher than in a conventional soil with the same soil organic matter content. On the other hand, I use drip irrigation, which keeps a smaller soil volume moist than sprinkler or furrow irrigation. So nitrogen mineralization in the dry soil will likely be lower. So I'm trying to think about the different aspects of my operation that are going to impact the mineralization rates, and using those to account for the number that I estimate from the tables versus what might actually be happening. So I estimated 66 pounds and I adjusted it down just a little bit. Okay, so what available N might be coming from crop residue, either cover crops or post-harvest residue. So the previous crop was incorporated in the fall, so I'm not going to account for that. But I did grow a cover crop, so I'm going to focus on estimating nitrogen from my cover crop. So I'm going to first work on number 11. How do I estimate my biomass dry weight? So in this paragraph, I described that I used a cover crop that is a legume oat mix. So I'm going to look for resources on how much biomass is coming from a legume oat mix. And on the right-hand side, I have a document that was developed for this area showing what some of those estimates are. So if you look on the right-hand side in that table, you'll see a mix number 2 or mix number 3 that are both fall planted legume oat mixes. So I looked at those and decided to, and those basically estimate around 5,700 pounds, 5,600 pounds. And this was terminated in April. And I have these pictures above to also see how much biomass these fields are representing. So between the pictures and the table and the timing, so, oops. I say here that I terminated the cover crop in March. So it's about a month earlier than this document. And I can also see that my cover crop's a little bit smaller. So I decided to discount my biomass by 1,000 pounds. But also, because it was a month earlier, I expect that my C to N ratio will be a little bit lower and my total N percent to be a little bit higher because that tissue is younger. And so, for number 11, I referred to that article and I used the mix described there and planted at 100 pounds per acre and waited for the first rain to germinate the seed. I terminated the cover crop in March, about a month before the sampling took place. So I discounted my biomass by 1,000 pounds. And also looking at the pictures, my crop was not as tall as in the photo. So I lowered the C to N ratio since it was not as mature as in April. So I went with 4,600 pounds. And then to establish the percent N, as I described, I expect it to be a little bit higher since I terminated it earlier. So I adjusted it from 2.9 or 3 to 3.5%. So now I need to calculate in all of that biomass, how much nitrogen is there? So 4,600 pounds times 3.5% gives me 161 pounds of nitrogen per acre. So I have that here. Now I need to think about, of that nitrogen, how much is going to be plant available in those first 6 months after termination and incorporation. So I'll start to think about and use this figure where we have our tissue nitrogen estimates. So I went with 3.5% nitrogen. And so I can look here and estimate somewhere between 35 and maybe 55% of the residue would be mineralized. So I'll want to pick a percent within that. I wrote here, I'm incorporating my cover crop into soil with some moisture to encourage degradation so I can plant my tomatoes in it in early May. I estimated at a 12-to-1, so that's on the low to intermediate side of release. I'm using a legume cereal mix, which releases at an intermediate rate due to the higher carbon from the cereal crops. So skip this table for a minute. I decided to go with 30%. So I'm going to multiply the total nitrogen times my estimated mineralization rate, and that leaves me with 48 pounds of nitrogen per acre. So I put that into this box. That is my total N from cover crop available this season. So we also give a small example that's separate from the story we're telling right here, but just to give another example of how to use these tables. Excuse me. So in this case, we have residue with 2 different percent nitrogen leaf tissue. And they both have the same amount of biomass, but so the total N is going to be different. It's multiplying 6,000 times 5% will give you 300 pounds of total N or 180 pounds of total N. And so to estimate the nitrogen mineralization, using this figure below, figure 5, so at 5%, 58% mineralization was chosen. So 300 times 58% is 174 pounds. At 3% nitrogen, 30% N mineralization is estimated. So 180 times 30% leaves 54 pounds of available nitrogen in the shorter term. Okay, next, looking at irrigation water. So this is a pretty straightforward calculation. However, you need to have an estimate of your total water use. So your total, and then you also need to have a report of how much nitrate N is in the water. So 30, and if you have your, you have that report, which is in ppms, you can convert it here. So we had a test result of 8 ppm, 5/7/2018. So we took 8 ppm times the conversion factor of 0.227 to give us 1.1816. So we took our total water use of 30 acre inches times 1.816 pounds of nitrogen per acre inch, and that gives us 54.5 pounds of nitrogen. So we put 55 in as the contribution from irrigation water. We assume that's all available. Okay, next, we're going to go through the amendments. So we'll start at the top. Compost, what kind of compost did you use? And it's a yard trimmings compost. So the first step is to identify the C to N ratio of the compost. And I got this by requesting an analysis from the company. So I put 15 to 1. Identify the amount of water that's in the compost. Again, this will be on the analysis that the company has given you. So 35% water. Oops. How much total N is in that compost? That's going to be a 1%. This is again given as a dry weight basis from that analysis. So this is all coming from a report that the company can provide you. And all compost companies will provide you with an analysis if you ask. So that should be easy to get. So what's your application rate? So I applied 10 tons to the acre. And it arrives at my farm as is. So the compost leaves the supplier at the rate that you ordered and at the as is rate. This is a little bit tricky sometimes to determine if your supplier has made adjustments to the tonnage they sell you to account for water, the weight of water. So if you can find out that information, then you can better estimate the amount of nitrogen that's in that volume of material. So for illustrative purposes, I walked through an example of adjusting a 35% moisture level of a compost. So I apply it at 10 tons to the acre. I'm going to adjust that for 35% moisture. So it's actually the equivalent of 13 pounds of dry material. So at 1% nitrogen, we are going to be adding 130 pounds of nitrogen per acre. Now trying to estimate the available N from the compost. With having percent N, you can use this figure in which you want to look for 1%, and that hovers right around 0. You can also use table 5, looking for your percent N, and we know that it again hovers at 0. It can sometimes immobilize nitrogen. We have -3 here, or it can release a small amount, like +4%. So in this case, I chose 2%. So 130 pounds of nitrogen times 2% is 2.6 pounds of nitrogen per acre. So I rounded that up to 3 pounds of nitrogen per acre is my estimate of what's coming from the yard trimmings compost during my growing season. You can also use this figure to estimate your available nitrogen, so that release rate. And you can see that blue line, which is composted yard trimmings, hovering right along 0. So it will guide you similarly. Next, let's take a pelleted chicken manure product. The bag says it's a 422, so it's 4% nitrogen. So that's about 0.04 pounds of nitrogen per pound. The application rate is 500 pounds to the acre. So the total nitrogen applied will be 0.04 times 500 pounds. That's 20 pounds of nitrogen applied. So how much of it is available? What's our total available N? So we can use the figure on the right, figure 8, and we have an example of a granular fertilizer that's 4%. And that estimated available N hovers about 50%. So I chose 50%. You can read the script below. The fresh market tomatoes are being grown in the summer under irrigation. So the release rate will not be limited by cool or dry weather. The fertilizer in a band above the drip tape so it stays moist, and that encourages the release. And then I look at that figure to see that a 4% granular fertilizer will release about 50% over 12 weeks. So 20 pounds times 50% is 10 pounds of nitrogen per acre. Okay, moving on to liquid fertilizers. In this case, you get the fertilizer density. Remember that water is 8 pounds per gallon, so the fertilizers are usually not too different. If you can't find the density, you at least have 8 pounds to work with. And then you have the percent N of the product, which is going to give you that from the label. So 5%. The application rate, I applied 50 gallons over the season. So I'm going to apply 9.15 pounds per gallon times the 5% times 50 gallons per acre gives me 22.875 pounds of nitrogen per acre. So I round that up to 23. Now, how much of that is available? The liquid products in general tend to be quite available. In the table below, we have liquid fertilizers at 65 to 70%. You can see here they hover at 70%. We have some data that supports that the animal-based, like fish emulsion, liquids tend to release at a little bit higher rates. So I chose at 85%. So 23 times 85% is 19.5 pounds of nitrogen per acre. So I rounded that up to 20 pounds. Okay. We're almost there. We've got some soil tests we can think about including. So we took a soil test in February, and it had 55 ppm of nitrate. Okay, so you see that it's nitrate, not nitrate N. So we're going to do the conversion. So 55 ppm divided by 4.42, we're going to get rid of the weight of the oxygen and just get the nitrogen. So that leaves us with 12.4 ppm of nitrate N. And so then we're going to convert that 2 pounds per acre. So we'll take 12.4 ppm times a conversion factor for bulk density, and that gives us 44.6 pounds of nitrogen per acre. So we expect there to be about 45 pounds of nitrogen from our soil test sitting in the soil and plant available. So we're going to include that. So looking back now, we go back to all of those boxes and we tally them up. We enter them into our budget. And when we do that, we end up with a expected available nitrogen grand total of 226 pounds. And so we can subtract that from our crop demand, which we estimate at 240 pounds. And that leaves us with a negative balance of 14. So that's extremely close. What we expect to be available is extremely close to what we expect the demand to be. So now that I've completed this, my current regime is close to supplying sufficient nitrogen to my fresh market tomatoes and the high yield that I expect. However, it is quite close and could fall short. To monitor sufficient nitrogen during the season, I'll consider taking a soil sample right before planting and/or right before rapid growth to inform a side dress or liquid application. And in addition, I will take leaf samples, so tissue samples. So in this way, you can look at all these contributions that you're adding or that are in your soil, organic matter or residual soil, and get an estimate of where you fall in your expectations of available N and crop demand. And as you can see, there's a lot of estimations that are happening. And so this is really a guide to help you get somewhere close to understanding if you're far from sufficient or within the ballpark. And it really is critical to be complementing your best guess predictions in a worksheet like this with the field truthing of soil analyses and tissue analyses, and of course, your own observations on yield. So I'll stop sharing. I hope that gives folks a resource to be able to reference and get a sense of how to put this all together to create a complete picture of what you're working with. So I'm glad that everybody has followed that. And like I said, this is based on a real scenario that a lot of the growers I work with follow. And so this has been a helpful, simple and complete summary of a nitrogen budget. So Patricia is going to walk through a scenario that she's working on. And through this process, you'll get to understand and hopefully see how to think through situations that might be a little bit more complex or different from the one that we've presented. And so as you become more familiar with the nitrogen dynamics, we hope that you will begin to be able to manage some of these scenarios that fall outside of the cookie cutter examples and the data that we have, so that you can start making your own best guess estimates to address your own scenarios. So Patricia is going to welcome you into her thought process of how to tackle other scenarios. Okay, you can take it away, Patricia.
All right. And I encourage you at any point, put questions in the chat or unmute yourself, interrupt and ask questions. I'm hoping that this can be a discussion, not a lecture. So this is me working through a scenario with an organic grower, M3 Ranches in Yolo County, who actually the grower is on the call. And so Colin, if you want to interject at any time or field any questions, you're very welcome to. The setup is they have a good amount of organic tomato acreage, and wondering if the current program is providing sufficient nitrogen. They're noticing some fall off towards the end of the season. And so what I wanted to do was go through with the information from these fields to see what does the end budget look like and how can we use those end budgets to make some educated guesses about what would be a good way forward. So I'm going to go through the same process that Margaret just did. We'll predict the crop need, predict the nitrogen that's going to be available from the soil organic matter and from the irrigation water, predict the nitrogen that's available from amendments, and then checking the nitrogen program using soil and plant testing. So have data from two different fields that are pretty different. They're both growing processing tomato. Our expected yield is both about 50 tons per acre. The first field has a lower organic matter. It's still pretty high for the area, 2.2%. The second field has a very good organic matter content, 4%. I'm assuming that these values were taken in fall. They also provided residual nitrate values, both of which are pretty low, 9 and 11 ppm. And the program is 10 tons per acre of a green waste compost in fall, and 3 tons of poultry manure in spring. And for the analysis, I just used some common numbers that I've seen in local materials. These are pretty early planted, March 27th, and I'm saying they're about 125-day crops. So harvest around the end of July. Irrigation water nitrate tests show that it's pretty low, about 1.1 ppm nitrate N, and I'm assuming around 27.5 acre inches applied per season. And for both of these, I'm saying the previous crop is sunflower that's incorporated the previous fall. So I'm not going to assume any direct N contribution. But it's an interesting consideration that this residue is being incorporated around the same time as that green waste compost. So getting the crop nitrogen demand, again, I'm going to that table 1 on page 8712. And in this case, very straightforward. The sample yield is the same as our expected yield. So I'm going to say we'll expect to take up around 250 pounds of nitrogen per acre, and assume about 5 pounds of nitrogen taken up per ton of yield. Soil organic matter is going to be a lot less straightforward. First of all, an interesting question. We recognize this table of predicted mineralization from soil organic matter. But am I only interested in the nitrogen that's being mineralized during my growing season? So starting in late March, or should I also count the nitrogen that's being mineralized earlier in the season, or maybe even after the sunflower crop? So a couple of different considerations here. One is, in this scenario, we applied green waste compost, I'm saying, around in October. At around the same time, we incorporated the residues from the previous crop. So there'll be probably some tie-up of residual nitrogen. I'm also, tomato is a pretty deep-rooted crop. So if we're getting leaching below the rooting zone, it's likely that some of that will be able to be recaptured by the crop as it grows. So even if it's not immediately available, it may be available later on. And because it's kind of hard to disentangle, and I don't have data for a spring nitrate test, for all these reasons, I think that it makes sense in this case to also count the nitrogen that I think is going to be mineralized over winter. So for my 2.2% SOM field, I'm just taking the average between the 1.5 and 3. So I get an estimate of about 50 pounds of nitrogen per acre for the top foot. But then we come to an interesting problem. Tomatoes are pretty deep rooted, and there's good evidence that they're utilizing the nitrogen from the second foot of soil. And so how do we estimate what it might be getting from that second foot? And that's something you'll notice we haven't really talked about in this workshop. Daniel touched in his presentation briefly on some of what might expected to be mineralized, but then there's a couple of different considerations. There's what's mineralized, and then there's what's taken up by the roots. And so kind of have to think about the system. In processing tomato, this is subsurface drip irrigated. And so that can be around 9 to 12 inches. So we may actually be getting a pretty good cluster of roots around the bottom of that first foot and into that second foot. So you might be getting some pretty good uptake there. On the end, we might actually, in the top foot, some of that topsoil might be dry, might not be mineralizing as much. But that's difficult to take into account as we're doing a budget. And part of the reason that I'm doing this budget is because I want to see, is it possible that my program is providing enough? And so in this case, what I've decided I'll do is take kind of what I think is a reasonable upper limit for the mineralization and use that as my number. So if I'm mineralizing as much as I think is reasonable, what would that kind of upper level be? So what I decided, I looked at Daniel's presentation where he documents the nitrogen that they saw mineralized from the top 2 feet of soil in several representative fields. The total was around 75 pounds of nitrogen per acre. And this is goes along with some other literature that I've seen that around 60 to 90 pounds is a reasonable estimate. So I'm saying in this lower organic matter field, I'll assume 25 pounds for a total of 75 pounds of nitrogen per acre mineralized from the top 2 feet. And then for my 4% nitrogen, this is going to be a lot more. For the top foot, I'll take that 3% column and just add a third to it. This gives me about 88 pounds of nitrogen per acre. And then I'll just use the same ratio. So I said half from the lower foot in the first field. I'll estimate half from the lower foot in the second field as well. So that would give a total of about 132 pounds of N per acre mineralized from the top 2 feet. Irrigation water, that's much more straightforward. We had 1.1 ppm of nitrate N. I have my amount of water that we use. So 1.1, conversion factor of 2.27 gives 1/4 pound of N per acre inch. So around, I'm going to round everything, 7 pounds of N per acre from the irrigation water nitrate. Moving on to the compost, we have 10 tons per acre of yard waste or green waste compost added the previous fall. So I'm saying 1.5% N in the dry matter, 16:1 carbon to nitrogen ratio. Because it's applied the previous fall, I'm going to look at the availability for 9 months. I get from the calculator when I plug these in, about 150 pounds of nitrogen per acre is applied. And of that, between 5 to 10 pounds per acre is available. Again, because I'm looking at the upper limit of what might be expected, I'm going to take 10 for that number. And just as a note, you'll notice on the calculator a place where you can put in soil properties. This is if you're using a very high C to N ratio material, it'll need extra nitrogen from the soil in order to break it down. And so if my C to N ratio is like 25:1, then it would become important that I add in differences in residual soil nitrate or soil organic matter just to tell the calculator how much N do you have to work with to decompose that. But because this is a fairly low C to N, or it's below the break-even point, the compost doesn't need much additional soil N in order to decompose. So it'll be similar between the two fields. We'll assume that for the same amount of compost added to both the high and the low organic matter fields, we're assuming that about the same amount will be available. Next, we'll calculate how much we get with the poultry manure. This is applied in spring, and I'm going to say March 1st, so about 4 weeks before the planting date. I'm saying it's about 3.2% nitrogen, 8.5 C to N ratio. And here's what I get. I get a range 45 to 63 pounds per acre. And notice for the calculator, I put in 6 months as my time of interest. This is interesting when we think of what the actual uptake, when the tomatoes are actually taking up the nitrogen. We're harvesting before the predicted end date, but by then it's already pretty much mineralized all it's going to. So I'm going to take the same range, and most of it is done. I didn't do an exact calculation, but this is probably like late green fruit stage by the time most of it's taken up. So most of this seems like it will be available within the timing that the plant is doing its quick uptake. So when we plug these into the budget, this is that first field with the 2.2% soil organic matter. So we're estimating at a 50 ton per acre yield goal, 250 pounds per acre. Add in soil organic matter mineralization from the top 2 feet, irrigation water, and that gives us 82 pounds of nitrogen per acre. And then from the compost, we're getting a total of 73. So add those together, 155 pounds of nitrogen per acre. So this is quite a considerable difference. And again, all of this takes a lot of estimation. But again, we also put our estimates kind of at the higher level. So this field, it seems likely we're probably undershooting on the nitrogen. For the second field, the soil organic matter contributes much more. So there you're getting the payoff of that 4%. So using the same process, same amount from the amendments, our available grand total around 212. And so still potentially some shortfall from the yield goal, but much closer. Quick detour. We have numbers from the residual nitrate in these tests that were taken in fall. The first field was 9 ppm, the second field was 11 ppm. So if we use our conversion factor for the top foot, 33 and 40 pounds of nitrogen per acre, should we count that towards the total budget? And I'm just including the text here. This is from the 8712, and I think it's helpful in kind of deciding what do we count, when it was measured, how do we count it? The text here, similarly, if soil samples are more than several months old, consider what activities have since occurred that could influence nitrogen levels, such as crop production, rain, amendment, application, and so on, to decide whether or not these numbers are going to be useful. And when I think about these, assuming that they were taken after the sunflower crop, but before the green waste compost, all of that sunflower residue needs to break down. If we look at this chart again, October, November, and a little bit into December, the soils are still pretty warm and we're still mineralizing quite a lot. So we'll have some tie up, we'll have some more mineralization. Hopefully we're getting rain, we'll have some leaching. And so my conclusion is that these values aren't going to be that useful for the budget for this current year. And I won't count them towards my total because of everything else that's going on in this field in those months between when I took the sample and when the crop's going to be taking it up. So here we are. And now what? Field 1 seems like it likely won't supply enough N to achieve the yield goal. Field 2 is much closer, may or may not. So how do we decide what to do that's going to be help increase the yields, that's going to be cost effective, and that's not going to give other negative externalities? So how to predict if more N is really needed, what's the most cost-effective way to get it, how do we approach thinking about cost-benefit analysis, and then what are some other important considerations? So just to reiterate, spring soil testing is going to be very important. So this is a figure from Danielle's presentation on soil testing and on coordinating supply with demand. So this again figure depicts the nitrogen that's predicted to be released from all of these different sources over time. And the bank that you build up around when that crop is going into rapid growth phase will be probably the most reliable indicator that we have of, is it going to be adequate to support that rapid growth? This figure on the right here, this is some research that Tim Hartz did, where he looked at several different organic processing tomato fields across California and did a lot of measurements, but among them was looking at the soil nitrate in the top 2 feet 3 weeks after planting. And then they did leaf analyses and looked at yield. And in this figure, the yellow bars are the fields that were the later leaf analyses showed to be nitrogen deficient. And so based on this data, they found that when you're below here on the y-axis, that 10 ppm of soil nitrate, that's a pretty good indication that you haven't built up enough stock of available nitrogen here to really support that rapid growth. They found that under 10 ppm, you pretty frequently got nitrogen deficient plants. And so just to put some cushion on it, they said below 10 to 15 ppm nitrogen in the top 2 feet 3 weeks after transplanting was a decent indicator that you might want to think about a side dress application. For leaf tissue testing, it's a useful tool, but for processing tomatoes for organic nitrogen, it's more useful for assessing your nitrogen program than for in-season assessments. And that was because when you take it pretty early before that period of rapid growth, it might not show any deficiency because what's there by the roots is enough for their current needs, but isn't really predictive of what their future needs are going to be. So if you look at this little graph here, these green dots, these are samples taken early bloom. So no real relation to the soil nitrate. Whereas when they took the samples at full bloom, when it's going into that period of rapid growth, then that's when it started to show more relationship to soil nitrate. But of course, if you're side dressing, that might not be enough time for you to add the material, let it mineralize, have the plants take it up in time to prevent loss of fruit set or whatever it is. So again, it might not be useful for in-season adjustment, but very useful for seeing whether your program was sufficient. So for both tracking over time and comparing to published values, both for nitrogen and for looking at other nutrients. For example, if a program uses a lot of poultry manure and you see your phosphorus increasing to very high levels over time, that could be an indication that maybe moving to another type could be good. And just as a reiteration of this, this is an excellent resource for many California crops for interpreting leaf tissue testing. So again, as Margaret was saying, mostly taken from large-scale conventional agriculture, but for interpreting sufficiency, deficiency, and excess of different leaf nutrients. And then a final piece, and this is more experimental, and this is something I'd really like to get input from the growers on, who are in this workshop, is thinking through practicality and cost effectiveness. Is it really going to be worth your while to get as much yield as you possibly can, given how expensive organic fertilizers are? And they don't all have the same pluses or minuses. So a couple things just to think about back from Crop Science 101. If you think back to that table, we found that kind of on average from the literature, 5 pounds of nitrogen uptake for every ton yield, but that's not going to be linear. We know from experience that the more deficient that a crop is, the more likely it is to respond to the nutrient that it's deficient in. So you may get, this is the classic crop response to nutrients curve. On the x-axis, you have increasing concentration of the nutrient in the plant tissue. On the y-axis, increasing yield growth or plant growth or yield. So at the more deficient it is, the more likely you are to get a benefit from that added nutrient. As it becomes less deficient, you'll get less response. And finally, if it's not deficient, you can keep on adding that nutrient. It won't do you any good. And then similarly, thinking about, are there other yield limitations? So this is another classic figure from Crop Science 101, the leaky bucket. So if you're adding a lot of nitrogen, but it's really potassium that's limiting, you can add a lot of nitrogen and not get any yield increase unless you also add potassium. Or that limiting factor could also be weeds or heat or something like that. And so with those, with that kind of introduction, I did some thinking about how would I approach assessing the cost effectiveness of some different sources. So these are just example values. These are some that I was able to find prices for online. But let's say I have guano and a feather meal. So I found a price per pound. Again, this isn't all guano, all feather meal. These are just some that I found online. But yeah, so this is the exercise I went through, just thinking. So I'm able to find prices for 2 different materials. I have the analysis. Oh, whoops! I realized I made a mistake in this one. I said it was 11%, but it's 12%. Anyhow, so I'll fix that error when I put it online, but it didn't make too much difference. So the pounds of nitrogen per pound of fertilizer, and then using our the tables that we've gone over through in this workshop, how much of that N do we expect to be available? I'm saying 90% for the guano, 65% for the feather meal. And then thinking about how much of that nitrogen do I actually expect to be taken up by the plant. I'm going to use an 80% nitrogen use efficiency, and then use those to calculate what's the cost per pound of available N. And then my back of the envelope calculation, assuming that 5 pounds of available N means 5 pounds of uptake, means a ton of yield. Can I pay for an extra ton of tomato yield? And our organic tomato price this year was 145 per ton on average. And so looking at this exercise and with these two different sources, I would say the feather meal just on cost alone might be a better bet than the guano. But there are a lot of other considerations. Both of these are really high analysis, quick release materials, but they need to be released by microbes. And so if you apply them at really high rates, you actually poison the microbes, and you can poison the plant. So that's one thing. These aren't things that you want to apply at high rates. You can think about the other nutrients that they apply. You can think about how quickly they're likely to release if it's something that's done as a side dress. And then also just another potential source, what about cover crop? Can we do something similar? Which again, there's so many logistical considerations. So the cost per unit N is definitely not the only one, but just working through what might that be. So in this exercise, I'm saying 3% nitrogen cover crop, kind of similar to how Margaret calculated. Assume I have a grass legume cover crop that was about 3% N, 5,500 pounds of acre biomass when I incorporate it. There was a cost study that was recently published, so I just used the value from the cost study. How much does it cost to produce 1 acre of cover crop? And again, this is based on 2022 water prices and labor prices. And in these cost studies, they go through, these are the assumptions that are made in order to help you adapt it to your own situation. But so say about $156 per acre. How much total nitrogen can you expect it to have? And again, I'm basing that on that percent N in biomass. Calculate total percent N, same N use efficiency. And so I can get just a back of the envelope cost per pound of available N. So as you can see, which is not a big surprise, it's something we've been saying, very considerably cheaper a cover crop versus some of these fertilizers, but there's a lot of other considerations. A big one is termination. You need to be able to terminate it in time to plant in time. You need to be able to terminate it in time so it doesn't get huge and full of carbon, low C to N ratio, give you nitrogen tie-up. There's uncertainty of stem establishment. You don't know what species composition you'll get. But then on the plus side, you're getting other soil health benefits like improved infiltration, runoff and erosion. And a big one, building soil organic matter. Again, remember that was the big difference between the two fields, was the soil organic matter. So I'm not going to end this presentation with any answers. I'm hoping to end it with more discussion. But if I was to approach thinking about next steps, that first field, deficiency is pretty likely in it, and the shortfall is, I believe we said, we're guessing around 95 pounds of nitrogen per acre. This is going to be bigger than we could realistically think about fertilizing our way out of. And so I would think about approaches for this one that are cheaper per unit nitrogen and more carbon rich to try and build that soil organic matter more if possible. And again, that can depend a lot on texture, on other things, how much soil organic matter a field can actually build. So I might consider increasing the poultry manure just this spring, and then taking soil samples to see if a side dress application might be useful, and consider the practicality of a cover crop just to give that big slug of nitrogen that might be needed. And of course, it's not necessarily something that's just going to be relying on the grower. So discussing with the processor and figuring out in the larger context if that's a practicality. For field number 2, with much higher soil organic matter, this one might have a deficiency, might not. This one I think would be more a target for, or targeted use of enriched sources. And again, taking soil samples, using some of those thresholds, the 10 to 15 ppm threshold. Does it seem like a side dress fertilizer application might be useful? And then also because it's really tricky to know how much yield you'll get. The idea of considering trying out the side dress just on a few rows in the first year, seeing if you get higher yields and if it seems to be likely to pay off the expense of the fertilizer. So I'm hoping that I have stimulated your thought processes of how you'll approach your own, and looking forward to some discussion.
Thank you, Patricia. That was fantastic. All right. Do we have any thoughts or comments?
Oh, I'm seeing some comments in the chat. Somebody asked, what do I mean by poisoning the microbes? Like literally ammonium is toxic and ammonia is toxic. And so when you get really high levels all at once from mineralization of some of these materials, you can actually kill microbes in a zone around where that's happening. So this can actually slow down mineralization from these materials. So I've seen this in banded guano, where we actually, I think partly like the soil was not as wet as it could have been as well, but where we still had considerable amounts of guano there at the end of the season. And that was at least my theory of how that happened, because we saw these really high concentrations of ammonium that the plants just weren't really taking, that the plants weren't really taking up. And you see that sometimes in the literature too. I don't know if, but basically the take home being very high rates of these high nitrogen fertilizers can be counterproductive. And then another question was, what was the 10 to 15 ppm nitrate level? That was the one that I flashed on the screen real quick from Tim Hartz's work on organic processing tomatoes. I'll put up that graph again real quick. Yeah. So that comes from this work. If you see that graph on the right, on the y-axis are across all of these fields, the soil nitrate concentrations in the top 2 feet from soil samples taken 3 weeks after planting. And each of the bars on the x-axis is a field. And so the yellow bars are the field where the leaf samples said that these were probably nitrogen deficient. And so they used this data to give kind of a rule of thumb. If you take these soil nitrate samples before the period of rapid growth, and you see that they're less than like 10 to 15 pounds of nitrogen per acre, pounds of nitrate nitrogen per acre, you might want to think about supplementing. So that's what I meant when I talked about that threshold. That threshold will not be the same, or that's a threshold that was calibrated for processing tomatoes. It's not necessarily going to be valid for other crops. But there is some data on this, and I don't know if Daniel, if you wanted to chime in, kind of where people, what thresholds might exist for other crops if you're looking at soil nitrate levels early season, and you want to be able to use those to know, should I fertilize, should I not? Am I likely to get a yield boost?
Very challenging establishing threshold in organic systems because the nitrogen mineralization after that can vary so much. So now I don't know other literature where they looked at thresholds in California for organic systems.
Patricia, there's a comment in the chat or question, why so much green waste compost early in the season when vegetative growth must be maximized and the end contribution from green waste is so low? You also increase in the C to N ratio, making mineralization slower.
Oh, that's a really good question. It's useful for building the soil organic matter. So it's applied in fall to avoid tying up nitrogen, and evidence so far from California suggests that applying green waste compost in fall, it doesn't mineralize enough over the winter to really cause much leaching. So the leaching risk is pretty low, but applying it the fall before gives it time to break down more. So you're improving your likelihood of availability. And then for the high rates, I'm assuming just to increase the organic matter as much as possible. I guess the thing to remember about C to N ratios is that they aren't static. So as the microbes are first breaking down the material in the compost, they're reducing the C to N ratio. And then as they continue to decompose it in the soil, they're reducing it still more until the carbon to nitrogen ratio of the soil itself is around 10 to 1, which is fairly similar to the carbon to nitrogen ratio of microbial bodies. So it varies, but just because you're adding a low C to N ratio or a high C to N ratio material doesn't necessarily mean that you're tying up more nitrogen in the soil. It's just, it's all about the timing. So yeah, does that make sense? Or does that answer your question? And I guess as I'm reading it more, yeah, just important to note that like this big slug was added the fall before. It wasn't added in spring.
And it reminds me too of some of the research that some advisors on the coast are doing of using a high C to N ratio compost as a way to capture residual soil N from the previous crop. So if there's a concern or a high percent nitrogen in the residue crop, that there'll be a lot of nitrogen post-harvest thinking about using the high C to N ratio compost as a way to capture some of that nitrogen and keeping it in the upper part of the soil profile. Patricia, there was a request to show your last slide again.
Let's see.
Where did that go? The going forward considerations.
Yes, and again, for me, I'll have to say this is quite speculative, and it's something that I'd be very interested to hear from the growers in the workshop. Any input or feedback that they would have. You know, what would be your first thought when you
Trisha?
Yeah.
So an approach for field 1, it says use cheaper per unit N and C rich. You're saying do the C rich option because we can apply these sources earlier before planting, and the microbes will have time to like break up to start processing it, and then we won't have to worry about nitrogen lockup.
Yes, and especially when compared with fertilizers. So manures, composts, and cover crops are all much cheaper per unit N than fertilizers. They're safer to apply in large amounts and help to build the soil organic matter over time. And so to me, these seem like safer approaches for helping to increase the nitrogen in field 1 than to try and make up the deficiency with something like a guano or a feather meal that wouldn't necessarily build the soil organic matter and might fry your plants if you tried to do it in large enough quantities. So that's where that thought came from.
Okay, thank you.
There's a question about whether plasticulture impacts the soil environment enough to change mineralization rates versus without plastic.
Oh, that's a really interesting question. I imagine it would, because I imagine it would change the temperature, but I'm not thinking of numbers off the top of my head. Daniel or Margaret, is this something you've studied?
Yeah, I too don't have numbers, but I think of the same thing, thinking about the increase in the soil temperature early in the spring. A lot of my growers who do use plastic with tomatoes tend to do it for those earlier plantings, specifically for that reason. And I have heard anecdotally reports of helping, although the nitrogen demand isn't very high early on, having some available nitrogen for plant establishment can have a nice impact on the yield later on. So the early spring weather can sometimes limit some of that early available N. So I know that that plastic can help increase that soil temperature and make sure there's enough nitrogen for a good plant establishment. But yeah, I don't have data for that or for the timing later on. We're in a hotter climate, so it's usually not done later in the season. Does anyone else have experience with that? Okay, we have another question. Do you risk nitrite toxicity if you load the soil excessively in the spring and it rains heavily to drop the soil oxygen and the surface sufficiently to cause reduction?
See, Daniel, you can chime in if you have anything else. I have not heard of that. it slows down mineralization, and you can often get ammonium buildup, or that's the situation that I would associate with ammonium buildup. I haven't heard of nitrite toxicity, or I haven't run into that. But I don't know if Daniel or Margaret, if you have.
No, I haven't heard of nitrite toxicity for crops either.
Think yeah. We have a question about aged horse manure. And that's something I'll have to do some reading and get back to you on. I haven't done work with that yet. One thing I do imagine is that you can, kind of like with everything else, look at the carbon to nitrogen ratio and look at the percent nitrogen and get some idea. If you see a carbon to nitrogen ratio of 50:1, you know that it's going to tie up nitrogen, and you know that it's going to take a while. If you see something that's 13:1 and it's a manure, that can be pretty volatile, because some of that carbon might be in really labile form and some might be in more stable form. So there with manure, it gets a little bit tricky, but the more aged it is, probably, my guess is that the less that will be an issue. But I would say a good starting point is generally going to be look at the carbon to nitrogen ratio and the percent nitrogen to get an idea of what it's going to be comparable to.
Thank you. There was a remaining question from session 2 that was asking about leaving the materials on the surface versus burying it. And I wanted to bring up this slide that Daniel presented in the first session, in which 2 materials, there was a 442 and a 1200, were applied, and one was left on the surface, these 2 solid lines, and the other was buried. And on the vertical axis, you see the percent nitrogen released. And so for the 442 products, for the material that was surface applied, about 35% of that was released when it was surface applied, compared to around maybe 55% when it was buried. And looking at the 1200 product, when it was surface applied and not incorporated, a little more than 30% became a plant available, compared to around 85% that became plant available when the product was incorporated. So I hope that addresses that question. We will prepare a document like we did for session 1 with the answers to your questions from session 2 and session 3, and I'll add those to the Google Drive doc. There were just a couple remaining ones that we hadn't answered yet in the session, and that was one of them. So I will send out a notice when we have that document in the Google Doc for you.
We have a question on compost tea, which is something that I'm not very familiar with, but wanted to see whether you've done any work on. Seems like there is a lot of interest in compost tea amongst growers. Is there any evidence to support that application of compost tea through drip irrigation or micro sprinklers could increase mineralization of applied composts or higher C/N ratio amendments? So this is something I'm not too familiar with, but Margaret, have you run into any work on this?
I haven't run into any work, but I agree that I see that happening a lot, and the growers report seeing a nitrogen benefit from running what would not be considered fertilizers because the percent nitrogen is really low and or it's applied at very low amounts, such that if you were to do the calculation of pounds of N applied, it would be just a few pounds at best. And so the response is not what one would expect given that amount of nitrogen. However, I frequently hear it talked about that those products could be supplying labile sources of carbon that can stimulate the mineralization process that's of materials that are available in the soil but need some sugar, some carbon to stimulate the mineralization process. Like molasses is one of those, for example. But I haven't been involved with studies looking at that. It's a great area to explore because at least among my growers, it's a pretty standard practice that people do and see those benefits. Daniel, have you come across much data looking at these low end products as a sort of spoon feeding? I hear it talked about like a spoon feeding approach during the season.
I've not looked into it, no.
Jean, we haven't looked at tree crops. We would like to have a perennial crop version of this workshop, but we haven't been able to do that yet. We realized early on that they were pretty different systems and it was not realistic for us to even generalize. So we kind of steer clear from talking about tree crops.
The question, how would you change your N fertilization program if you plan to participate in the groundwater recharge program?
Good question.
Which, of course, a big consideration would be when you're applying your labile fertilizers, which ideally you wouldn't be doing prior to the time when you'd also be doing groundwater recharge anyhow. But that would be the main thing that I would consideration that I would take into account. I guess another thing which we haven't talked much about, but for people that are evaluating their program is an interesting approach is deep soil sampling post-harvest. This is a way to, it's a lot of work, but it's a way to do a check on how appropriate your program is. If you're seeing accumulation of nitrate at depth, this could be a sign that there's too much N or it's coming at the wrong time, or that it's leaching past the root zone. So that's one thing I would think of if I was considering for myself doing groundwater recharge, is paying some more attention to the residual nitrate at the end of the season, because you're deliberately leaching it down and you can't necessarily be like, oh, we'll just pick that up by planting a grass crop later or something.
I agree with Patricia. If you have several fields you can choose for groundwater recharge, you will probably choose the field with the low, you should, if possible, choose the field with the lowest nitrate concentration in the soil, because if you do recharge and maybe a foot or so of water, it's most of that nitrate that's there at the end of the season will be gone by spring when you're done. So select the field, or you probably have a pretty good idea if you do some nitrate testing, which crops leave less nitrate behind than others. So choose a crop with less nitrate in the soil. That will probably be a crop where the residue has a wide CN ratio, rather than a crop, let's say broccoli, that leaves behind residue with a very narrow CN ratio that decomposes very quickly and adds to the nitrate pool after the harvest.
Maria, would you mind dropping the workshop evaluation in the survey?
We have one more very good question, or possibly
Yeah,
more
we
than
can
that,
keep
but-
chatting.
Yeah, yeah. From a practical standpoint, when you are growing a diverse crop mix of annual vegetables and flowers, is it acceptable to take a more generalized end budgeting approach, averaging the typical end demand of most crops and all of your known end contributions, and then addressing any heavy feeders via liquids or granular top dressing? But yes, generally, how you approach when you have a very large mix of crops.
Yeah, I have that situation pretty frequently with the growers I work with. And although there is a wide range of crops, there do tend to be some of the top high value crops. So in my case, that would be the fresh market tomatoes and melons and maybe peppers. And so they tend to have a little higher acreage and are really important to the overall business plan. When I work with those growers, we tend to take a little bit of a focused look at those crops and make sure that they do the best they can do. And and they have enough acreage too with those crops that the practices are handled at a field level as opposed to a bed level. So yeah, isolating kind of the most important crops if there's a couple that emerge. And if not, I think your proposed concept is good. I would take a good look at the demand, the nitrogen demand, and the timing of demand for all the crops that are maybe sharing a nitrogen management budget, and trying to find the averages, but also find what the limits are that you don't want to go under, such that you might be seeing some crop loss. And as you say, maybe doing some targeted supplementing for those crops that are going to have a higher nitrogen demand. Cover cropping and compost are also kind of, as Patricia was saying, like safer ways to be building the soil organic matter and kind of that nitrogen bank, whereas the fertilizers tend to be more available and kind of short term. So that's another way to think about it is you could bolster the whole system using those compost and cover crops and getting benefit to meet the higher demands that way.
There are many reasons determine which crops you want to grow together, but if there's a possibility to group the heavy feeders together and the light feeders separately so that you can fertilize groups of crops, that may simplify your management too. But it's not always possible, of course. There are many factors that play into that, which crops you want to grow together.
Oh, and that reminds me, Daniel, that the crop that precedes your crop will make a big difference too. And so, what's done for tomatoes might differ slightly if it was following corn versus broccoli versus flowers. And so I think also considering the impact of the preceding crop to the budget becomes even more impactful with these diversified systems, because it can change so much as to what was happening before this year versus next year and the future years. And so trying to account for that among all the changing factors and variables in diversified systems. I'm trying to catch up on some questions here too. So overall, I'm getting a message that feather meal pre-plant is less efficient than side dress. If you have good organic matter percent, then skip the pre-plant N.
I feel like it depends on a lot of factors. One of them would be, when are you planting? just mineralization is going to be faster if you're planting in the summer, or if you're planting later, like May, versus if you're planting in February or something. And so with some planting times and with some crops, it may be useful to actually have a fair amount of mineralization happen before. I've been doing a lot of, like, I work a lot with tomatoes where they're sitting in the ground, not doing their transplants, and they're sitting in the ground doing not that much for quite a long time. And so a lot of what I talk about is sort of based on that assumption, but it probably wouldn't be true for something like, I don't know, spinach. So temperature, that's one consideration. Yes. Also, the timing goes into how the likelihood of leaching. So I'd say definitely sometimes, but not necessarily. And the main thing to think about would be that timing between when you want it available, when it's going to be taken up, and what are the risks of loss by especially leaching. But
Yeah, to piggyback on that, one scenario that can get growers in trouble is when we've had a wet winter and the cover crops aren't terminated as early as was initially planned. And then now folks are backed up and trying to get in the ground as soon as possible. And so you have more biomass that's higher carbon going into the soil, and yet less time for that to break down and mineralize. And so that can result in a nitrogen deficient or a tie-up and immobilization, a temporary immobilization at transplant. And that can impact early plant establishment. So I have one organic grower I work with who's an excellent and very experienced grower, will add a manure-based compost at that time to stimulate that breakdown and try to accelerate that that early immobilization during plant establishment. So kind of thinking about the impact on plant establishment specifically, I think is a important little consideration in that window of time at planting. And as you've seen, organic growers tend to be front-loaded in nitrogen. And so it's not a standard problem, but there are these situations in which you can have tie-up early on. So yeah, keep that in mind.
oh, we have a hand raised, Benjamin.
Hi, thanks, Margot. Just Margaret, a real quick. When you said you have a grower who applies a nitrogen application, was that at transplant or was it at when he's incorporating the crop?
At termination and incorporation of the cover crop.
Yeah.
Yeah.
Thank you.
Yeah, so he'll incorporate a little bit deeper and add a compost and make sure that the soil is moist to kind of maximize the decomposition rate of that cover crop so that he can get in as soon as possible and not have immobilization issues.
And is there a particular N C to N ratio or percent N that he's looking for in that compost when he's doing that?
No, but it's not a yard trimmings compost, so it's not a high C to N ratio compost. Yeah.
Thank you.
Mm-hmm. How quickly should I expect my soil C to N ratio to change with organic matter supplements? Oh, were you typing that answer, Patricia?
I was, but I would welcome other input as too. That's a really interesting question because it gets at the idea of what is soil organic matter and what is the C to N ratio. So your soil C to N ratio will change right away when you add a cover crop. But it fluctuates. And so there's kind of how quickly can it go from low to high to low again? Like how quickly can you immediately change it? And then over time, can you get a higher or lower baseline? So I guess that's interesting and makes me want to, I don't have a good answer off the top of my head for how quickly can you get a different baseline. You certainly can, but I'm not sure how quickly it happens. And I think it would depend a lot on what you're using to, what your inputs are and what your climate is. That you can get immediate changes from the stuff that you're putting in, but they won't necessarily be stable.
So when you look only at the soil organic matter, which means the highly decomposed organic matter in the soil, it is often around 10, and people have analyzed soil samples around the world in different ecosystems. It's always kind of around 10. And the reason is that most of the soil organic matter is actually made up of residues from dead microorganisms. So unless you recently added a lot of material that has a very different CN ratio, I think the CN ratio of the soil organic matter remains relatively stable over time.
So I guess that also gets at the same question, because if you're continuously adding something that, say, has a low C to N ratio, then you could potentially get the same effect. This comes from doing some research comparing a long-term organic rotation versus a long-term conventional rotation on the same soils type in Tennessee. And it was one of the major differences between them was a considerably lower soil C to N ratio in the soil that was getting a lot of manure. But that also makes sense. If it had had a fairly recent manure application and it was getting those manure applications every year, then it really gets at that question of what is stable soil organic matter. So yeah, I guess that's how are we defining stable? How are we defining soil organic matter? But if you're continually feeding it with something that has a different C to N ratio, then practically, I guess the C to N ratio might differ.
Okay, we have one more question. What science has been done to support the dogma that UN32 is toxic to the soil? This is a popular claim with healthy soil folks.
I'm not aware of any research that's shown that it's toxic in the soil. We have done a literature review with data from long-term trials where we looked at the effect of mineral fertilizer on soil microbes, microbial biomass, and we couldn't find any evidence of toxicity. The only cases where we found that it had a negative effect is with anhydrous ammonia. These anhydrous ammonia, because it's ammonia, can have a toxic effect on soil microorganisms. And in fact, early on, anhydrous ammonia was actually promoted as a fungicide, I believe. But other than that, we were kind of surprised, but we couldn't really find any evidence of direct effect of toxic effects on soil microorganisms. I think the reason why you hear that very often, that people say, well, mineral fertilizers are bad for soil or decrease soil organic matter content or are toxic to soil microorganisms. I think it always depends on what you compare. If you have a field where you apply over many years organic matter and then you switch to mineral fertilizer, then you will definitely see a decrease in soil organic matter and in the soil microbial biomass. But it's not really because the mineral fertilizer is toxic to the microorganisms, just because you no longer apply the carbon, so they don't have the food anymore. So you starve them, but you don't kill them with your fertilizer.
Thank you, Daniel. Okay, we have a fun scenario in the Q&A. I have an unusual situation on a field I was preparing to plant in the spring of 2024. We amended with 10 tons to the acre of green waste and 500 pounds to the acre of a 432 fertilizer. Then I had to take the rest of the season off from farming, fallowed the field, several cultivations to control Johnson grass, and then in the early summer, no activities. We planted garlic in November in this field, but repeated the fertilizer program because I thought most of the N value from spring was lost. How much residual N would you expect from the spring applied fertilizers? Well, it'd be great to get out there with your little test strips and check it out. So I hope that's a tool that you have at your disposal now, because that would be for 25 cents or even less maybe. You can answer that question and at least get a ballpark of what is remaining. Daniel, what were you going to add?
Yeah, I totally support that. I think that would be a very good case where you to do a nitrate quick test, or if you don't have it, take a representative sample of the field and send it to a lab. I think it would be worth the costs, because it's so hard to say. So I couldn't even give you a ballpark estimate of what happens during the entire summer in that field. There are so many variables. So that would really be ideal for the soil nitrate test, quick test, or send one sample to the lab.
I imagine in that example that it was not irrigated in the summertime, right? It was just a fallow. So the Johnson grass was just growing off of residual moisture. So the dry soil will help keep that nitrogen in the top couple feet of your soil profile. So I think that's a very different situation than if the reverse had happened, in which it was added in the fall and you had the wet season following it. Okay, well, we're almost out of time. I'm impressed that we filled the hour with questions and discussion. We have such a great group this year, lots of curiosity and good thinking. So we'll just take a few more questions and take us to 3 o'clock. Wouldn't, let's see. Yes, well, George, you're asking about the, I'm sorry, my Zoom screen just changed.
Sorry,
that-
that was, I just typed it.
Oh,
into
okay.
But yes, he was asking about the toxicity effect and if that was similar to what Daniel was just describing. And yes, yeah, that's where it comes from, is just the generation of ammonia. If you get very rapid mineralization in a small space. I've seen this happen or documented in studies with very quick release and organic fertilizers, but I don't have good thresholds. It's just something people periodically report. But I'm not sure if I've seen any systematic study of the effect.
So there's a question about the impact of winter drought, or if you were in the groundwater recharge program, the impact on beneficial soil microbes for your spring nutrient mobilization. Microbes have a very robust sort of boom and bust population cycles. And so they can, they're quite responsive to these changes in food sources or conditions, whether that's drought or temperature. And when we look at how these practices are affecting the microbes, it's often talked about in these sort of population boom and bust cycles. And that's part of what's generating the nitrogen release when they die, and release nitrogen. And so soil microbes, unlike plant pathogens, are very adapted to changing soil conditions, whether that's drought or temperature, etc. And so they can go into dormant stages when the conditions are insufficient for growth. And so they have various life adaptation strategies to deal with these changes. So that's my thought on how a dry or very wet season would impact those microbes. I think they're still there in the soil, and will be available for, if there's a carbon source, if there's food added to the soil, or if they're fed, or the conditions change, and that would impact your spring nutrient mobilization activities. Any other thoughts from Patricia or Daniel?
No, I agree. I think microbes, they have the preferred conditions where they grow, but they can really adapt and to survive or be inactive in soil when the conditions are not good. And as soon as the conditions change and are good for their survival, they can multiply very quickly and be back.
Well, I was gonna, another question is about the effect of timing on soil health. So the question is, if I split fertilization into different applications with a meaningful interval, then would that be beneficial to soil health? And that's a follow-up from the question about potential for toxicity. And I would say it would be kind of an exceptional circumstance that would lead to toxicity. Like that would be applying a very high nitrogen fertilizer in a band at quite a high rate. So I would think of the toxicity issue as kind of the exception, not the rule. But it is an interesting question about the effect of timing on soil health. I would say probably in most situations, it would make more sense to kind of fertilize to the plant needs. Kind of just thinking about when is the plant going to be taking up, or I guess like Margaret was talking about, if it ever makes sense to fertilize a little bit to help break down residue or something like that. But I would think of it in terms of what do you want the fertilizer to be doing, and have that be the philosophy that leads it, that leads your approach to timing.
In soil, microorganisms are often carbon limited, so they appreciate a constant supply of carbon. That doesn't need to be just organic amendments, but there's also root exudates or crop residues, cover crop residues. But if they get a constant supply from some source, I think that can be beneficial for soil health, just to keep them feeding.
Yes, carbon is the currency of the underground world. Yes, you can find nitrate test strips easily on Amazon or other sources. I think sometimes pool stores have them too, but of course Amazon's available to most everybody. Does the use of soil sulfur to manage bicarbonates affecting infiltration negatively impact soil microbes?
I did some research looking at this. It can. pH has a really strong effect on soil microbes, but that said, it has to be pretty extreme Most soils are pretty well buffered. And also microbes are in general pretty resilient. So it can have an effect, but it's not very, you wouldn't expect it to be very long lasting. And you probably wouldn't get that much of an effect unless you're doing really high rates of sulfur all at once. And that's something as well that kind of splitting it up over time versus doing a big slug might help reduce the negative effects if it's something that you're concerned about. But I can send you a study on this.
Thank you, Patricia. Well, folks, it's 3 o'clock. So I want to thank you for being such great students and participants in our workshop. It wouldn't be as much fun without all your questions and interests. And a big thank you to Patricia and Daniel and all of our other speakers who do such a great job putting these presentations together and studying, devoting their work to studying these questions. And a thank you to Maria for your technical support and Diego for your translations. And I think that's it. Please do answer our evaluation. We just love hearing from you and are really passionate about this workshop. So we value your input. And thank you so much, everybody. Your commitment to 4 weeks is noticed, and we hope that you've gotten a lot of value out of all your time and commitment to doing this. So thank you so much. And wish everyone a happy holidays and happy new year. And we are a resource to you in the future. You know how to find all of us. We are public employees, so we're here to help you as you continue on your journey of learning to manage our soils organically. So thank you so much, everybody.